Okay, good morning everyone, and welcome to week 3 for the Geo-Python course. Hopefully, those of you who have already joined on Zoom have found the link to join the poll. So Woko has just also posted that link to participate in the poll about what you learned during week 2. You can see the address as well here underneath the question, as Woko has very nicely thought to put that someplace visible so that you can join in and give your feedback if you have any about the second week of the course. As you'll remember, our main topic last week was related to Python lists, but we did also spend a good amount of time talking about version control using Git and GitHub, and I suppose that all of you have had practice with that as well in the exercise. So yes, if you're still kind of getting settled in here, please feel free to add your comments or your votes to the poll here about week 2. And maybe I will allow Woko to also say hello and...
Yeah, good morning. So please share your thoughts. How are things going? So I think you grasped quite well what you were supposed to learn last week. So lists, indices, version control, markdown, all that. And the second question was about how's it going with Git. And based on a quick look, things are going well. Somebody is still confused. We'll keep repeating the workflow every week. So if it's still a bit confusing, I'm sure you'll get the hang of it within a few weeks. So we now indeed use the Git plugin, which I think was a good choice. Some of you might then later on start using Git from the command line as well. But here the main concepts are quite clear. Getting the hang of it. Good. And then we had a third question about pair programming, which is a new addition in the course. Good to have backup, worked well, had a nice pair. Are we going to have corrections to our exercises? I'll come back to that in a second. Good, constructive, great. Not sure we made everything by ourselves. I hope you then at least discussed if you have had some differences. Okay, well, at least this feedback is positive. We will share kind of an anonymous, you can answer anonymously or with your own name to give us feedback on how things went. And if some of you didn't, for example, ever contact your pair or things like this, we will sort those out during this week's exercises. So of course, some students might drop out. We of course hope you continue with the course, but some people might not continue. So we might have to regroup some of the pairs. But yeah, good to hear that it went well. And maybe on the feedback, so by today, I think all of you should have received feedback on exercise 1 in your GitHub repositories. So you can go to github.com Geo-Python 2020 and your personal exercise 1 repository, and our efficient assistants have looked through your submission. If everything is well, you maybe got a thumbs up or something else. And if there were some problems or something to fix, then you maybe received a bit longer feedback. So these first weeks are all about getting everybody up to speed with the tools, basic Python syntax, and so on. Yep. Does Dave have anything to add on the pair programming or?
Yeah, well, maybe just a couple minor things. First off, I'm very pleased to see that the pair programming looks to have gone well. We had no expectations about how that would turn out. And of course, we're aware that working in Zoom is not as natural for pair programming as it would be if you were sitting side by side. But I'm personally very pleased to see positive feedback about this. And I hope that that will continue as the course moves forward and as you get into some of the other exercises. In the first few weeks, the exercises are I wouldn't say that they're easy necessarily, but they're perhaps a little bit less demanding than the exercises that are later in the course. So maybe you rely less on being in a pair at the moment, but you still benefit from it. But it gets you used to working together, because I think in weeks 5 and 6, that's often where the students seem to be having a bit more challenge with the exercises and taking a bit more effort, I think, to get to the solutions you end up in those weeks. Mm-hmm. I did want to note a couple things just before we get started that aren't necessarily related to this feedback that's on the screen now. One of them does have to do with the exercise, just in general. I noticed, at least, and maybe Vuoko noticed the same thing, I received quite a few notifications from GitHub last night between the time I went to sleep and this morning about people cloning their repositories, creating the exercise repository, and I went to sleep pretty late, so that's not great if you're starting the exercise so late. You can probably get away with it now, but as things go forward, once we get into weeks 5 and 6, you're not going to be able to start the exercise the night before and finish it most probably. So just a warning at the moment that there's nothing wrong with starting the exercise at the last minute. I often work that way myself, and that's fine, but it's going to be much more difficult to manage in the later weeks in the course. So it might be a good idea to start at least having a look at the exercise earlier in the week so that you have a good sense of what you're going to need to do and can then plan ahead in terms of how much time you might need. Mm-hmm. So that was, one note about the exercises. One other thing about Git, I don't know whether any of you have tried to use Binder for this exercise number 2, but if you did, you probably had problems. The GitHub plugin for Jupyter Lab, it works in principle on Binder, but it has an issue at the moment that basically causes it to lock up. And you might have noticed if you tried using Binder that it just says that the web browser has become unresponsive, and maybe it asks you to close the tab or wait. I've disabled the plugin for now, so you won't be able to use Binder with Git, at least not with the plugin. If you want to work from the kind of command line interface for Git, you should still be able to do that in Binder. But until they fix this little bug with the integration with Jupyter Lab, then unfortunately, we basically have to rely on either using your own machine or using CSC notebooks for working on the exercises for the foreseeable future. So you won't be able to use Binder. But you could still use Binder, for instance, for the lessons if you want to. And if you have friends who are not in the course or something and you want to show them, just that they can play around with things, of course, Binder is okay for that. So just wanted to note that as well.
Yeah.
Go ahead, Vuoko.
No, just good point about the exercises. I think already this week the exercise is more extensive, especially if you don't have any previous experience with for loops and conditional statements, which is the topic today. And another technical note before we go into the lesson soon. So you could already start to launch your Jupyter Lab instances while waiting, and you should see a lesson 3 folder in here. If you don't see it, I can try to help you via chat starting from now, or then there is this Geo-Python Lite instance, so that should at least work. So last week some of you had problems not seeing these folders, and it has to do with Git. Won't go into details, but if you can't see the lesson materials, let me know, and I'll be here monitoring Slack and the chat when Dave starts the lesson.
Yes, good idea. Are there any questions at this point from any of you, like about things we have not covered in the feedback or anything like that? Because if not, perhaps I could request that I will share my screen.
Yes, let's do that.
And we can switch over here. All right, so hopefully you can now see my screen and see the main page for the course website here. as you know, we're on to week number 3, so we can start here by taking a look at the lesson overview. And essentially, our topics for this week are we're going to talk about mainly 2 things. One is loops, and particularly we're going to talk about for loops, which are a construct in Python programming language that allow you to repeat a section of code a certain number of times. And so we'll talk about how to use for loops, particularly in combinations with lists. Those 2 things nicely go together. And then we're going to talk about conditional statements. These are basically ways in which you can make decisions in the code to execute different parts of the code depending on certain conditions. And again, we will give you some more information about that when we get into those parts of the lesson. So we have 2 Python lessons this week, and then we'll have our good coding practice that we'll briefly mention. About the lesson materials themselves, I did want to note one thing, and I don't recall whether we mentioned this back in the first week. Perhaps Walko can correct me if she happens to remember. But the materials that we're using in this course are going to be part of a textbook that we're working on that should be coming out sometime in 2021, possibly in the spring. It would be ready and then available maybe later in the fall. But these materials for the Geo-Python part of the course, we're basically planning to use many of them directly as parts of the lessons in this textbook. And along with that, we're hoping to take advantage of you as people who are reading through the lesson materials to help us in finding any kind of typos or finding things that are unclear, making notes of issues that you might see in the text. So for instance, if we just jump back for the moment to our basic elements of Python lesson, if you, for instance, found some kind of typo or you thought that something needed to be explained in a little bit more detail, there is the possibility to go up here to this little pencil thing and click Edit this page, which would allow you to go to the notebook itself. Now, for the notebooks, this is going to be a little bit perhaps difficult to directly edit because what you see is the notebook as a text file, and it might be a little bit hard to find something in there. But if you can find the text that you were referring to, you could basically go and make a change inside this file. So I don't know what I would do, but I could make some change, and I don't know, let's say I just deleted a word. And then what you would be able to do is you should, if I'm not mistaken, be able to go here, say some commit message. This is basically just using the GitHub interface. So you could say, suggest editing to be more clear. And then what you could do is, I think that for all of you, you will not have this option to commit directly to the master branch because you don't have permissions with your GitHub usernames to edit our course materials directly. But I believe you should see an option that would allow you to either create a new branch for this commit and start a pull request. A pull request essentially is a request to merge a change in a file into our main version of the code. So you could, for instance, check this, and then it would give some suggested name, davewhip-patch-1 or whatever. You could change this name if you would like. And then you could hit propose change. That's going to basically make this thing called a pull request. And so we've created this new branch, and then you could create the pull request by clicking the green button here that would essentially make a request to us that we can see that you think something should be changed in one of the files. So if I click create pull request, then this you can see now here, at least in my view of our course webpage GitHub repository, there's now a thing here called a pull request. And if I click on that, I could see, for instance, this new request to make a change to the code. And I could go then and take a look, for instance, at the commit that's associated with that, see what changed. I would see, okay, one word has been removed. And then it's up to us as the organizers of the course to make a decision about whether we want to integrate that change. Now, just to give you some potential incentive, of course, if you do make any comments, if you have any suggestions about how to change the text or the lesson materials in any way, we're going to, of course, be very grateful for your comments, but also we'll be glad to acknowledge you for your feedback when we do put together a list of acknowledgements for the textbook when that is finally ready. And in case you're interested, I'll just show you the web page here is for the current version of the book. The book will be available both in print and online, and all of the book materials will be available online without any need to pay to access those. The web address that we have the book at now is pythongis.org. And if you go there, you just see now currently our landing page, but it lays out the pieces of the book that are going to be assembled in the coming months. So this part 1 Python Essentials is more or less the stuff that we're covering in the Geo-Python course. I don't actually think there's much more here right now than just the titles. So you can see our basic programming concepts. That's about where we are in Geo-Python right now. Then we'll get into data analysis with Python in weeks 5 and 6, and then data visualization in week 7. So this first part of the book is essentially straight out of the Geo-Python course. And for those continuing into the automating GIS processes, that's basically part 2 of the book. And part 3 will be some case studies where we apply what's learned in parts 1 and part 2 to geographic data analysis. So that's our book plug / request for you to give us any feedback. And Woko, I don't know if you have anything to add to that. Looks like no. So yes, then, if you have any questions or issues, if you try to give feedback and you're having problems, of course, you can just post things in Slack. And I thought about making a Slack channel for the book feedback, but I think maybe it's actually better if we do it as pull requests, because then you're going to give us comments directly on the materials that we'll be using in the lessons and in the text of the book. So yes, with that said, let's jump here now to our lesson for today. And I've mentioned already we're going to do for loops and conditional statements. And our first part of the lesson here is on for loops. And I'm going to then jump over here. Let me just open this up and get our CSC notebook instance open. So as Woko mentioned, you should hopefully have your notebook instance up. And if not, you can pull that up now. I am using the Geo-Python Lite. And so that should look basically like this. If you have used the same image, you won't be able to save files in there. So that is the one drawback. But I can see, for instance, here in notebooks and L3, the materials for this week's lesson. And we're going to start here with our notebook called forloops.ipynb. All right, so to get started, we can think about what the basic idea here is with the for loop. And as I mentioned at the beginning of the description of what the lesson is, they're essentially a construct in the code that allows us to repeat some part of a script, some part of a notebook, over and over to process items, for instance, items in a list. To give you a sense of why this is useful, we can start with a bad example. So let's consider that we have this list here of European cities. And so this is a cell that should already have text in it. You can just run that cell to create this European cities list, where we have Helsinki, Paris, Barcelona, and Uppsala. Now, if we wanted to print out each name of the cities in our list, we could use the print statement as we've seen before, and we could also take our list name, European cities, and as you recall from last week, we can use the index value to refer to the different values in our list. So European cities with the square brackets and 0 should give us Helsinki as the first item in this list. Remember again that the list index starts with 0. And sure enough, if we print that out, we see Helsinki. If we want to print out all of them, we could go old school and just copy paste, go change our number, copy paste again, and run each one of those cells and print things out just the way that we know it works. Tried and true, we can get away with doing that. Not necessarily a good way to go though, because if we try to use this same thing, say, okay, we have 4 print statements, but let's say we change our list. So now I run this this cell rather again with a different set of European cities. And if I take the text I had before, I can do print European cities 0, print European cities 1, 2, and of course, if I do things exactly as I did before, when I go to run this, I have a problem that my list index is now out of range because my list length has changed. And if I wasn't paying attention to that and I try to use the same set of steps I had used previously, I now have tried to access an item that is not within the size of the list that we're dealing with at the moment. So we get this index error. So there's 2 reasons why this is a bad approach. One is that you can imagine as the size of a list grows, this is not a functional or a sort of reasonable way to approach the problem because it's going to take you ages to type in all of these print statements one by one. If you have 100,000 items in your list, you're going to spend days copy paste, and very probably you're going to make mistakes along the way, and you're not going to get the output that you want that way. Secondly, if you had, for instance, copied all of these print statements to the same cell, so let's just do it like this, just for the sake of an example. If I put them all in the same cell, saying like, hey, I'll just print out all 4 at once in one cell. Boom, I can do that. Now, this would work, for instance, in the first case, if I went back and reran the first cell, redefined my list of European cities to be the original 4, print out those 4, everything's fine. But if I go and take that same approach down here, where I run this cell first to redefine my list of European cities and try to copy paste that same little piece of code, again, we get this index out of range error. So this is not something that's going to adapt nicely to the lists of different length. So we have, fortunately, a solution to this problem, and that is that we can use something called a for loop. Let's go here now and run this cell again with a set of different European cities. And at this stage, let's use a different approach. We're going to use a for loop here and say for, that's the for statement, for city, good thing I can spell, in European cities, colon. So for city in European cities, colon, and if I press enter, you should notice if you're doing the same thing following along that you get automatic indentation of the next line. And then we're going to print out city. So let's run this and then we can talk about what just happened here. As you can see, we get the same output we had before. In essence, we have our 4 items from the list individually printed out to the screen. And this works quite nicely because if we want to redefine our list of cities, so for instance, if we go to the cell down here, we could say US cities equals, and I'm just going to copy paste this text from right here. For our list of cities, we have Detroit, Chicago, Denver, Boston, Portland, San Francisco, Houston, and Orlando. We could basically take the same approach we did above. I'll just copy paste that. We'll change the name of our list from European cities to US cities. But we can do for city in US cities, print city. And if I run this, boom, there's all 8, no problem. What's going on here? Well, we have this for loop that's essentially going to go through, and for each thing in some collection, some list, some group of items, it's going to go to each one, and each time it runs through here for each item, it's going to assign that item to a variable that's given here called city in this case. So the first time through when this loop runs, city will be given Amsterdam, and then this variable city will be then printed to the screen. There's nothing else in this list of things to do. And so then you come back up to the for statement again. You get the next thing in the list of cities. Now Brussels, that gets assigned to the variable called city, and that gets printed to the screen, and so on with Lisbon and Reykjavik until the end of the list is encountered, at which point the for loop is done running. There's nothing else to do, and that's that. Same thing goes for what's happening with the US cities. If we want to look at this in very general terms, if we want to think about it in terms of what the basic structure of a for loop is, it looks something like this. So we have our for statement at the beginning. We have some variable name here. This can basically be anything as long as it's an acceptable variable name. So you can't give it some name like true or something like that. But for some acceptable variable name here in collection. And the collection could be a list, could be some other things. We'll see some other examples later on in the course. Then we have underneath here the set of instructions that will happen for each item in that collection. So for us, it was basically just a print statement where we were printing out our variable name to the screen. But you could do other things with variable. You could have multiple lines underneath there to do something like if you wanted to count the number of letters in each one of the cities, or see how many times the letter A occurred in the city name and then print that out. You could have multiple lines of instructions underneath here. But this is the basic format. The key things to note here: starts with the word for, ends with the colon character. In addition, everything underneath the for loop should be indented. And the typical indentation would be something like 4 spaces. That's very common in Python programming, to indent with 4 spaces. In fact, if we go back here and look at what Jupyter did for us automatically, you can see we have 1, 2, 3, 4 spaces as the indentation that automatically happens in JupyterLab when we create a for loop, because it recognizes this for statement. It sees the colon here and says, ah, it's a for loop. I know the next line has to be indented underneath there. When you come to the end of the loop, there is nothing needed to indicate the end of this for loop. All you do is just change the indentation back to the normal indentation, or basically not having the 4 spaces, and the code will then continue on from there. These kind of loops, for loops, just as a note, they're basically intended to do something a set number of times. There are other kinds of loop structures in Python. A for loop is going to go through and do things a set number of times. In this case, it would be the length of the collection that you pass would be the number of times that something's going to happen. As a way of thinking about this, because for loops are going to be something that are fairly fundamental, I would say, in terms of a programming concept, but also something that we rely on a fair amount later on in the course, it's useful to maybe have an analogy or something you can think of in your everyday life that relates to a for loop. And there's a sort of silly example here with the cat's daily planner, and perhaps you could think about this as for every day in a cat's life, it will follow these instructions. But you could also think about it in terms of your own life. For some day in my life, you're going to get up and you're going to do the same set of things, most probably, at least some of those things. So let's hope that you wake up. And perhaps you're going to take a shower, eat breakfast, brush your teeth, whatever. check the latest COVID news, whatever it is that, that you would do in your daily life. This is essentially like a for loop. You repeat the same set of actions for each day in your life. And a for loop works in the way such that if the number of days in your life was the collection here, the day would be the assigned variable. And here, we're not even using the variable day necessarily in this for loop, but we just want to know that for each day, as long as there's another day to go in my life, I'm going to repeat these same actions. And these would be like little functions that you might include in your daily life. So that's the basic concept of what a for loop is. And now we can move maybe to talking a little bit about some of the details of how for loops are working. I'll remind you that if you have any questions, you're of course welcome to ask questions in Slack or in the Zoom chat, and we will do our best to make sure that no one is just sitting there totally confused. Okay, so let's take a look at this variable that's used in a for loop. And in our case here, we now have a new list. The list that we have at the moment here is a set of weather conditions. So I'm just going to run this cell to define our weather conditions variable. And let's use the same structure we did before to print out the weather conditions. So we could say for weather in weather conditions, colon. So remember, for statement, variable name, in, and then some collection. In this case, it's our weather conditions list. Let's just print out weather. So this will go through our loop for each item in go through our list. For each item in the list, it'll print it out to the screen. So here we see rain, sleet, snow, freezing fog, sunny, cloudy, and ice pellets. So what is the point of doing this? Well, the point is that this variable that's defined in the for loop is just a regular variable. So that what we could do is we could say that with a print statement after the loop, weather is. So we're going to have a print statement here where we print out this text after the loop, weather is, and then we print out the variable value that's stored in weather. And you can see that after the loop, weather is ice pellets. That is the last value that was assigned to this variable weather when it passed through this for loop, processing each one of the items in the list. So it's just a regular variable. And the point in mentioning that is you do sometimes need to watch out that if you've defined a variable name inside a for loop and you do something later on in the code with that same variable name, it's possible that you may have unexpected behavior, or you may have used a variable that has previously been defined and not realized that that was the case. So that's one way in which we can loop over items using a for loop. That is to directly iterate or to go through each one item individually directly using the items themselves in the list. But there's another way that we can do this, and it involves something called a function that's called range. All right, so what we have here is a function that will allow us to define a list of numbers. So let's just run the cell here first and we can see what we get. So we have here now for value in range 5, print value. If you run this, what you'll see printed to the screen is 0, 1, 2, 3, 4. What the range function is doing is it's producing a list of numbers for us that is 5 numbers long. So 0, 1, 2, 3, 4, that's 5 numbers. And the last value in our list here by default will be 1 less than the value here given for the range. Because the indexing starts at 0, to get 5 numbers, you would only end up at 4 as the maximum value or the maximum number in that list. So the idea with range, if you give it just a single number here, is that it gives you back a list of numbers starting at 0 that is the same length as whatever number you've put in here. And these will be integer whole number values. To get a sense of a little bit more how this range function is working, you can run here the help function. I don't think we've mentioned this previously, but if you encounter something in the Python code and you're not really sure how it works, you can always try running help and then putting whatever the function is inside the parentheses here. So we're going to do help range. And if you run this, you'll get a whole bunch of output here that describes in detail how the range function is working. So the important things that we can look at here would be that this returns an object that produces a sequence of integers from start, inclusive, to stop, exclusive, by step. What does that mean? Well, you could see an example here of using the range function where there's more than one thing, more than one value that's given. So with the range function, you can say, hey, I don't want to start at 0. I want to start with a different number. You could put that number in here, and that will be called start. You could then say, I don't want to end with well, your stop number is going to be basically the same. So you would put in some stop number here. So start, stop. But you could say, for instance, then for my step, I don't want to go up by 1, but I might want to go up by 5 or 10 or whatever. So you can put in the step as the increment for how much your value should increase each time you go one further in your range function. The inclusive and exclusive thing is something that's very important to be aware of. And that is that for start, the value that you list for start will be included in the list of values that's output by the range function. The value that you list for stop will not be included. That's exclusive. That's the reason, in some way, that when we give our range function example above, we did range with only the value of stop. So we had range 5, but you didn't see 5 in the list of values that was written out to the screen. You only saw it go up to 4. So that value that's listed here as stop will not be included in the list of numbers that's printed out to the screen. That's, again, just something to be aware of, because sometimes when you're using the range function, you're thinking one thing, but what you get out of the range function is actually not including stop, and that can mess up your way of thinking, especially if you say, like, I want to go from 0 to 50 in steps of 10. You might think 0, 50, 10 as your start, stop, step example, but that won't necessarily give you the output that you're expecting. All right, now it's time for you to check your understanding of how this range function is working, and also a little bit about how the for loops are working using the range function. So we have here a polling option where you can go and fill in your vote here for what you would have to put into this range function to get it to output the output that's shown here, 2, 5, 8. So what would you have to put in for your start, stop, step in range to get this for loop to produce the output that's shown there? You can go here and vote on your solution, and we will show the results of that voting in just a moment or two. Perhaps what I'll do is ask that once you have voted, if you could put your little green check mark in the participants list, then that way we can keep an eye on who has already voted and have a better idea of whether or not we should keep waiting or move on. So yes, go here to the poll. You should see the question here for the different options, and you could then think of which one of those things you would put in to get the desired output. Okay, well, that's about half, not quite half of the participants who've now voted. And I apologize if anyone's still thinking about this and not wanting to go ahead, but we should move on. So let's take a look at the output that we have here for the different votes. And we've got a little bit of a distribution, so that's a good thing. So which values of the range function would produce the desired screen output? We have 0, 9, 2, 2, 8, 3, 0, 8, 1, 2, 9, 3, 292 as all of our options. So we've had 46 votes in here. So maybe not everybody gave the green check mark in the Zoom chat or the Zoom participant list. That's fine. So the first value that's going to be in here should be a number 2. And on that basis, we can eliminate a few of these options because the starting value is always going to be included in the list of values that range produces. So any of those starting with a 0 aren't going to work for us because that would mean that we're going to have a 0 in our list of values that the range function produces when we should just start with 2. So we can eliminate these 2 right away. The next thing is the stop value. We saw it went 2, 5, 8. So the step that we can see there is a value of 3, and the stop, the last value that's shown on the screen, is the value 8. We have 2 options that are going to use a step of 3. For instance, 292 looks nice, but it's going to give us 2468 as the output here. But these 2 are going to go up in increments of 3, so 283, 293. And yes, the one here that has received the most votes, 293, is the correct option. Why is that? Well, that's because this second value that's listed here in the range function, the stop value, is excluded from the list of values the range function will produce. So 283 might look like the option that you want because you say, oh, I start at 2, then I go 5, add 3 more, I get to 8. Everything looks good. But this is the warning about the range function that that value is going to be excluded, so you have to go 1 higher with the range function to get 258 to be printed out to the screen by typing here 293 as the values in the range function. Let's take another look here quickly at that. So if we had our for loop here, we could do something like for value in range. There's our range function, 2, comma, 9, that's our stop value. 3 is our step. We're just going to print out value. So value in range, start value of 2 and value of, or stop value of 9, step of 3, printed out, and there we go, 258 just as expected. So this range function is something that will come back, and I don't want to say it's going to haunt you, but it's going to be around. And you might be thinking already like, why would we want to do this? What's the point? And we can get to the point of that here in just a moment. Let's take another look at an example of using this range function to print out values from a list. So this is an alternative way of interacting with values that are given in a list with a for loop. So here we have a list of numbers. You can see it's just called numbers, and it contains 5, 6, 7, 8. These are just 4 different numbers. Our task here is to print out the value that are in this list, each individual value, but instead of looping directly and using numbers as our list, we're going to use the range function. And this is a kind of common way of doing things in Python, where we can say, again, we're doing a for loop, but we're going to say for I in range. So we're using the range function here. I is going to be our variable name, and the length of the range, or the number of values we're going to have in our range function, is going to be the length of this list numbers. So you might remember the len function. That's going to give us the length of some list. So this is going to return a single integer value here, length, that will then create a list of numbers here with our range function that will be assigned to the variable called I. Now, in our example, we can say, let's say we wanted to do some basic math in here. So let's say that our numbers list at location I, so we're going to use the index value here and say our numbers value at this position in the list is equal to the numbers value that was there before. So numbers of I plus the value of I itself. So remember, this range function is going to give us a list of, in this case, 4 numbers, 0, 1, 2, 3. And each time through this loop, we're going to take whatever value we're dealing with from our numbers list and add to it the value of I. Now we could do that by itself. You won't get the output that way, so maybe it's also helpful to print a few things out to the screen to help us see what's going on here. So we could start out by printing the value of I. So we have a print statement here to say value of I, colon, and then comma, the variable I. So this will allow us to see what value has been assigned to this variable I each time we go through the for loop. We could also add another print statement here, and that would be for our value of numbers of I. And let's call this before addition. So before we modify the value of numbers, we can say print it out to the screen. And in the same kind of format that we had before, numbers of I, or so numbers with the position or index I. What this ought to do is print out whatever value is in numbers with the location, the index being given by the variable I. Finally, let's copy this line here, paste it down here, and we could say the value of numbers after addition. And so now we've modified value of numbers here. Let's print that out to the screen as well so we can see how things have changed. And then just for some nice looking output, we'll add an empty print statement here. It's just gonna give us a blank line after each time we go through this for loop. It'll allow us to easily see each pass through the for loop what is happening. So we've got our 3 print statements that are giving us some output. We've got some math that's happening in here, and then a print statement just to give us an extra blank line at the end. If I run this, right, numbers is not defined because I didn't run the cell above to define our list initially. But now if I run this, I get the following output here. So I have 4 sets of print statements. That's because I had 4 values and numbers here. So this for loop will iterate through 4 times. That makes sense. The first time through, the value is assigned to the variable I, because remember, this is coming from the range function with the length of numbers here determining how big the range will be. The value that's given to I the first time through is 0. So then the value of numbers at position 0 before the addition is 5. That makes sense. This is at index 0 in our list numbers. The value of numbers after the addition is also 5, which makes sense because if you did numbers at this position, so 5 plus 0 is going to give you 5. Second time through our for loop, the value of I has now changed to be equal to 1 because we've gone to the second thing that comes from the range function, second value in the range. Now the value of numbers before the addition is 6, and after the addition it's 7 because we do 6 plus 1 equals 7. Third time through, value of I is equal to 2. Go to this third item on our list and it's 7. Yep, that looks like it makes sense. 7 plus 2 gives us 9, and so on for the third value there. So in the end, if we print out what our list of numbers looks like after this, we can see the list has now been modified. So before it was 5, 6, 7, 8. Now it's 5, 7, 9, 11. So there's a number of things here that are described about what you can see in our example here. And if you're struggling, for instance, to see the relationship between the range function and the index values in our list of numbers, it's not an uncommon thing at all, don't worry. But you can read through the text here and get a sense of what this code example does. And it's really meant to just kind of walk you through how this for loop is working when you have a range function that's used in there. Now, why do we want to do this? This is a very valid question. Let's take a look at an example where using this for loop with the range function might make a little bit more sense. We have here a list of cities, including Helsinki, Stockholm, Oslo, Reykjavik, and Copenhagen. If I run this cell, I'll store those cities in a list called cities. And for each one, their corresponding country. So Finland, Sweden, Norway, Iceland, and Denmark. I run that cell, and that stores that list as countries. What we can do with a for loop now is we could make a nice looking print statement that tells us that each one of these cities is the capital of their respective country. If we were to do a for loop just looking directly over the values of cities, it's hard to then figure out which city corresponds to the country in the list here. But if we're using our range function, we could say something like for I in range len of cities. So again, this looks just like what we did before. We pick one of these lists. They're both the same length, so it doesn't really matter. But we're going to say for I in range len cities. We could then print that cities of I is the capital of countries of I. So we have our range function that will define us a list of 5 numbers starting at 0, and we're going to then use that to be able to go to the first item in our cities list is the capital of the first item in our countries list, and so on. Now if I run this, you'll see Helsinki is the capital of Finland, Stockholm is the capital of Sweden, Oslo is the capital of Norway, blah, blah, blah. This is perhaps one of the reasons why you might consider using this range function in general. And that is that if you have 2 lists and you want to be able to go and say at the corresponding location in both lists, or maybe you have 3, 4, 5, whatever lists, you want to go to the same locations and do the same things in those lists, or you want to access values from the same place in the lists. Let's say for some geological sample locations that you had a list of latitudes, you had a list of longitudes, you had a list of elevations, and you wanted to print out the locations of the samples in terms of latitude, longitude, elevation. You could use an approach like this by looping over the total length of the lists of one of those variables, whether it's latitude, longitude, or elevation. If they're all the same length, then you could take this for loop and then print out the lat, lon, and elevation of your samples using an example like this. All right, now this is our last thing here in our for loop example, another opportunity for you to check your understanding. And the question here is, we have 2 lists. We have odd numbers, we have even numbers. And you can see that in our odd number list, we have 1, 3, 5, 7, 9. In our even number list, we have 10, 4, 6, 8, and 2. And then underneath here, we have a for loop that does something. Now, rather than just copying and pasting this into the cell below, I'd like you to think about what kind of output you would expect from this for loop that's going to add together some odd number plus an even number at location I using the range function like we did before. So think about your answer, and then you can go here to the polling page and fill in your response for what you think the code here would produce. And again, please think about this first. Don't just run the code and then select your answer. And yeah, so we'll take a minute. You can fill in your responses in the poll. And once we are done with that, if you don't mind to put a green check mark in the participants list to let us know you responded to the poll question, that would be helpful. Strictly speaking, I don't think it's necessary because we have our screen here. But we have some voting going on already, and I'm just going to hide this for right now because I don't want you to be influenced by what the other people are saying. So take a minute to vote, and we'll check the responses shortly. Okay, so yeah, I don't see so many check marks in Zoom, but I do see that we have 45 responses already in the Pressimo poll. I can show you that here now. I guess you probably already have some ideas what's happened. And there is no discussion this time about what's going to happen in this example. So I suppose that's a good thing, that we would expect here that the program we have, this little snippet of code, would produce 11, 7, 11, 15, 11 as the output. Let's take a quick look at what we have and see if that makes sense. So we have our for loop for range in length odd numbers. That's going to give us a list here of 5 numbers starting at 0. So they'll allow us to use this as the index values. In each case that we go through here, we're going to print out odd numbers plus even numbers at the same location. So sure enough, we'd expect to see 11, 7, 11, 15, 11. And that makes sense here. Yeah, we're printing out the values of not things coming from the range function, so this solution is not going to be the one. The indentation error would happen if I copy this example here, just paste it down in the cell below here. Like if I didn't indent this print statement underneath here and ran this cell, here I would get an indentation error, because now it tells me, hey, you told me you're using a for loop, but you didn't actually indent anything underneath there to tell me the for loop's going to do something. So it says there's an expectation if you're using a for loop of an indented block. If I even indent it by 1 space, things work. Stylistically, I don't suggest doing that. It's better to indent by 4 spaces. In fact, I almost get the sense that Jupyter is telling you, like, this is not good if you indent with 1, 2, or 3 spaces. You can see the print statement's red. As soon as you get to 4, everything's okay. And if you go more than 4, it seems like that's also okay. So perhaps just in terms of the style of the code, I mean, this is really not so much a requirement in terms of the programming language in principle, but it's more like a style thing in Python that it says it's going to be a lot easier to understand your code if something that's associated with a for loop is indented underneath it, because it's very clear to the people looking at the code then what is in the for loop and what is not. So yeah, that's the indentation error. Okay, yes, we're not going to get just 11 because we have a print statement for every time through the for loop. So we would expect to see here that with this print statement, we get this output and separate lines. The last value that's outputted would be 11, but we would see the other values as well. 11, 11, 11, 11, 11. No, that's not going to be the case. And otherwise, we could rule out some of the other options here as well. I suppose that's fairly clear. So that's it basically for our for loop lesson at this point. Just to kind of recap the idea, I just want to remind you, for loops are used essentially as a way of redoing or repeating some piece of code over a list of items. So that whatever the length of that list is would be the number of times the for loop is going to run. In our cases here, for the length of odd numbers, we'd expect to have 5 times that we go through this for loop and do some kind of calculation. If we have a length of 50 cities, we would expect that 50 times this for loop is going to be used. And there's nothing like, if we go back to having our list of US cities from before, we had this list of 8 cities. You know, I could say for city in cities, or sorry, city in US cities, I don't have to use this variable city. So I could say, you know, cats are the best. And if I do that for my print statement, it's going to happen 8 times because there are 8 cities in this list, but I don't necessarily need to use this variable city at all. So the point here is that whatever the length of the list is, or the length of the collection that you use with your for loop, you're going to get that many times that the code that's indented here will be executed. So here we should see cats are the best 8 times. Or, you know, if you disagree, you know, dogs are the best. Or if you don't like things that are furry because you've got bad allergies, maybe you could say fish are the best, whatever. But it's going to happen 8 times regardless, because that is the length of the collection that's being used in the for loop. So with that, I think I will ask if there are any last questions about this part of the lesson. Seems like maybe there are not, in which case we can go ahead and take a 10-minute break, and we'll continue with the lesson at 10:33 or so. And Volker will continue with talking about conditional statements at that time. All right, so let's take a break and see you all in 10 minutes.